Hi everyone. Today I'm going to cover must-know math for the SAT exam. In particular, I will be covering functions. So these function problems, they have all appeared on previous past official SAT exams, and they have a history of repeating themselves, if not the same question, a very similar concept. So make sure you know these concepts in this video. So let's look at a couple of difficult functions. So here I have in the xy plane the graph of linear equation of the form y equals mx plus b and the graph of exponential equation y equals ab to the x power. Both contains points 1, 3, and 2, 4. Okay. If the point RS is on the graph of the linear equation on RT, and the point RT is on the graph of the exponential equation, where 0 is less than R is less than 4, and S is greater than T, which of the following must be true? Okay, well, for this one, I mean, we could find the equations of the equation of the line and the exponential equation, but I think we could also just see this visually. Because imagine it says that they both contain these points. So I have 1, 1, 2, 3, and also 2, 4. So around here. So the line I'll put in green. It goes through these 2 points. So look something. Well, it won't be perfect, but something like this, right? Okay, so it's going to through those 2 points. And then if the exponential equation also goes through those 2 points, then it's got to be like something like this. Okay, and then I'm asked if the point RS is on the graph of the linear function and RT is on the graph of okay, so they have the same x value, is on the graph of the exponential equation where 0 is less than R is less than 4, and S greater than T, which the following must be true. Okay, so if these 2 points are on, like this is on the linear equation, and this is on the graph of the exponential equation, for that to occur and for them to have the same x value, then it's got to be occurring like somewhere in between this area where they could potentially be touching each other. I didn't draw that greatly, but it looks something like this. And then like imagine you have the x coordinate here. So the x coordinate would have to, let's just say it's around here, could be consistent here, or it could also be perhaps here, etc. And then it would be a little bit higher or lower depending on the equation of the line or the exponential function, but it's going to fall within this range between 1 and 2. So definitely it's looking like option B. Okay, so if you want to be more precise with this, you can deduce the equations. Like I can easily find what the equation of the line is. I'll do slope formula. So 4 minus 3 and 2 minus 1. So that would be the slope is just 1. And then to find the x-intercept, so I have x plus b, then let's put in 3 equals 1 plus b. So I get 2 equals b. So the equation of the line is x plus y-intercept of 2, which actually looks nicely on my graph. And then likewise, I can do that with the exponential equation. So same, I can put 3 is equal to AB to the first power. And then I can also say that 4 is equal to AB squared. I can, let's see. So I can say 3 divided by B is equal to A. Then I can plug this in for our A value. Let's see what happens. So 4 is equal to 3b squared. This will cancel one of the b's. So divide each side by 3. So I get that 4/3 is equal to b. So then if I know 4/3 is b, so let's just go back. So 4 is equal to a. Now I put the b value in. So 4/3 squared. that would be 4 is equal to a 16 nines, and then divide each side like by 9/16 to solve for a d. So this I can reduce to 4. So basically, 9/4 is equal to a. So then final equation of the exponential would be our a value is 9/4. B value, it's 4/3, and then raised to the x. So now I actually have the two equations, and then I can just go ahead and make my life easier and plot it onto Desmos. Okay, so just so we can see visually, I put the exponential function deduce y equals the equation of the line and then the two coordinates that are supposed to be on the graph. And then we can see basically what I drew with my personal image, that for the coordinates RS and RT, they would for them to appear or be on parts of both the line and the exponential function, it's got to be occurring in between these 2 points. So it's happening in between this area, just to give a clearer view. But you can answer that how I did initially, just with um, you know, a little sketch like I did and some knowledge of exponential and linear functions. Okay. Hopefully that made sense and was amazing. Oh my goodness, let's look at this one. So f of x is equal to x minus a times x minus b. The function f is defined above, where a and b are integer constants. If f of 1 is greater than 0, f of 4 is less than 0, and f of 7 is greater than 0, what's one possible value of a plus b? Okay, well, first, this is definitely in roots form of a quadratic function. So, okay, so then looking at these, so I know one of the roots would be a, right? And then the other root or x-intercept would be b. Okay, and I'm told that f of 1 is greater than 0, f of 4 is less than 0, and f of 7 is greater than 0. So where f of 1 is greater than 0, it's positive at x equals 1, the function. It's negative at x equals 4. So I could say then that one root, let's say a must be between 1, 1 and 4. So I could say like 1 is less than a is less than 4. And then for the other condition, so I have less than 4 and f of 7 is f of 7 is greater than 0. So then it goes from negative at x equals 4, and then it goes positive to x equals 7. So then I could say that like the other root b must be between 4 and 7. So just, imagine me plotting this, like let's give a the value of 2, doesn't have to be, which is why they say one possible value. There's multiple possibilities. And then I could say, so we're gonna say a equals 2, and I'm gonna say like b is equal to 5. Okay, so that's one of the x-intercepts. So I'm gonna put that here at 2. And then the other one, 3, 4, 5, the other one here at 5. Okay, so I have my x-intercepts plotted, and I'm just basically asked for what the possibilities of a plus b would be equal to. Well, I mean, one of them could be 2 plus 5, which is 7. It could also be like I could have made a 3 and b is equal to 6. So another possibility could be 3 plus 6, 9. So also important, it does say integer, so I can't put any decimals here. But 7 and 9 could be possible answers. And also 8, I could do like 3 plus 5 as well. Does that make sense? I hope so. And I hope the x-intercepts make sense, because like I know this is a parabola. I know that the parabola is probably looking something like this. Like imagine it's in between these and it goes negative at some point. So it has to go positive, then go back to negative, and then positive again. So it looks something similar to what I'm sketching here on the screen. Okay, and just to show how you could work this on Desmos, so I could type in the original equation provided. Then I put my sliders in the same ranges I gave for B, which was 4 is less than B is less than 7. Um, oop, and then same, well, now I would have to fix that. Okay. And then A1 is less than A is less than 4. It says equal to, but we'll be able to see it just as it is. And then I put the parameters of f of x as being greater than 1, f of x is less than 4, f of x is 7, just to see how this will look when I put the slider on. And when I do that, I can see like this is potentially what it could be within the ranges provided. And also same with A, same thing, which is why there's multiple answers for this choice because there's different possibilities of where the parabola could be shifting. But as long as you get that the x-intercepts do occur between the range, it's got to be between A is greater than 1 but less than 4, and B is greater than 4 and less than 7. So, and that's basically what I was drawing over here. So that could be, the possible values would be 7, 9, and 8. Isn't that amazing? Okay, so I have the function f is defined by f of x equals 3 to the x. The function g is an increasing linear function. In the xy plane, the graphs of y equals f of x and y equals g of x intersect at 2 points, aj and bk, where j is less than k. And when g of x is greater than f of x, which of the following must be true? Okay, so if this happens on the exam, remain calm, and graph it out because that can help you see it better visually. So imagine I have f of x is equal to 3 of x. So let's say, let's plot some points. 3, 0. Remember anything raised to 0 power, well, just it's 1. So then I know I have one pair of coordinates would be 0, 1. Oops, 0, 1. Okay, likewise, if I did f of 1, it would have 3 to the 1. And this would just be that f of 1 is equal to 3, which tells me the x is 1 and the y value it's 3. Okay, so I can take these two coordinates and just roughly sketch them. Okay, so 0, 1 would be here. And if I look here, so this would be like 1, 2, 3, another point here. And remember, I know that this is an exponential function, so it will look maybe something like this. This is just a rough sketch. It doesn't really matter. The important thing is that I'm plotting the points here. So this is f of x. Okay, then I have some like increasing linear function. So I'm just going to make some arbitrary line. So let's, for example, just make it something like this. Okay, so it says AJ and BK intersect at 2 points, AJ and PK, where J is less than K. So this is telling me that the Y values of basically like Y values are higher. So like the K value, it's higher than the value of J. So let's just put then BK would be here because I want K greater than J. And then here would be, for example, AJ. Okay. Amazing. This would be g of x, the line. Okay, so now I can go through each of these options and see which of them is true. And remember, I am looking for when g is greater than f of x, which of the following must be true? Okay, let's go down into do. So when is g of x greater than f of x? That really only happens in this blue section here for like from the point to the point, right? So that's where I'm especially looking at to determine the answer choices. So I can see that I have like the
range going from here to here. So first option A, x is greater than k. That's not true between our range here. Is x greater than k? Not true. Eliminate. X is less than j. Also not true. X is less than j, not true. Or x is greater than b. Not true. And when I see, so A is less than X is less than B. So remember, this would be like, this would be A according to my drawing, and this would be B. And is it true that X falls between, that our X values are between A and B? Well, yes, that's exactly what's happening right here in my graph. From here to here, right? So my X values are between A and B. This one's true, so I can safely answer that option choice D is the answer. Okay, so amazing. But you see in this one, I'm the one who created the graph. The line didn't really matter so much. I can create it visually to see what the question is asking. Do this also on the exam if you have a similar question. Okay, amazing. Continuing our journey.
This would be, we could consider an exponential function. So here it says f of x is equal to 9 times 4 raised to the x power. And I'm asked which of the following equations represents the function g. Okay, so if g of x is equal to this, all I have to do is substitute this into the original function. So that would just be 9 times 4 raised to the x plus 2. Okay, so from here, always when you have exponents involved in the problems, you want to reverse engineer them. So looking at this, I can reverse engineer it because whenever I have addition with exponents, that means that I would have multiplied previously to have solved the problem. So this would be the same to say 4 to the x and 4 the 4 squared. Right, this is the same, bases are the same, it looks like this. It's another way to express that expression. So then I can just multiply 9 times 4 squared, multiply by 4x, and 9 times 16, that's 144. And then you can see I get the actual function, and I get it pretty quickly as well. Okay, but just remember, if you do have an exponent or exponential function, always consider reverse engineering because that could be the key to solving it. Okay, so let's also look at another one. Oh, very similar, but slightly different. So this one, I have 1.84. If you can't see it, this is an x. It's x divided by 4. It says it's divided by the given equation, and it can be rewritten as this, where p is a constant. Which of the following is the closest value to p? Okay, so I have my f of x is equal to 1.84 raised to the x over 4. Another way to express that would be f of x is equal to 1.2 the 1/4 times x, right? Because this would be the same expression. And then I can just now distribute that nicely. So this would be the same as 1.84, like raised to the 1/4, and then I can have x on the outside. So now I just need to see what that's equal to, 1.84 raised to the 4th power. Let's see. It's 1.16467, and going onward. So that's raised to the x power. And then remember, it says that this can be rewritten as, oh my goodness, it looks exactly like I'm trying to make it. So this would be 1 plus p over 100 x, and just to see the equivalences, right? Like this must be like 1 plus 16 over 100 raised to the x. So therefore, the answer must be 16. But you see how once again in this problem or this function problem, I took the exponent a step back to see what it could look like to make it mirror more the function rewritten in the problem. So always consider to reverse engineer exponents for function SAT success. Okay, so continuing our journey.
Continuing our journey. So here we're given a function. The equation above has point C4, okay, and 2C14, which means that, so like the f of x would correlate to the y value. So I can plug this in. So 4 is equal to a to the c minus b. And likewise, 2c 114, that would be 114 is equal to a to the 2c minus b. Okay. And then blah, 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 b is a positive number. What is the value of okay. I'm just thinking this one through, what I can do. Okay. So if I want everything in terms of b, okay, so for example, I could move this over and do 4 minus a to the c. Well, no. If I want to solve directly for, I'm just going to move the b's over. So sorry, 4 plus b is equal to a to the c. And then 114 plus b is equal to a to the 2c. Okay, then I'm going to square each side. Why am I doing that? Because if I do that, then this becomes a to the 2c. And then I can substitute this in here. So then I have everything in terms of b. So be 114b is equal to 4 plus b squared. And then, make sure that you expand your brackets. Okay, so it'd be 114 plus b is equal to 16 plus 8b plus b squared. And it looks like it's kind of turning into a quadratic. So next step, I'm going to put everything, bring the 14 over. So I have b squared plus 7b and minus 114 would be minus 98 equals 0. So if we could solve the quadratic, or I could also factor, it does factor perfectly. Usually happens in these problems. This is b plus 4, b minus 7 equals 0, which seems to make sense, right? Because 14 times negative 7, negative 98, and 14 minus 7 is positive 7. So my two solutions for b would be b equals negative 14 or b equals positive 7. And I'm asked for the positive number of b, so it's going to be b equals 7. Wow, what a great, amazing problem. An exponential function f is defined by f of x is equal to c to the x power, where c is a constant greater than 1. If f of x is equal to 9 times f of 4, what is the value of c? Okay, so let's define what f of 4 would be equal to c to the 4th power, and f of 6 would be equal to c to the 6th power. Okay, amazing. And I'm also told that f of 6 is equal to 9 times f of 4. Okay, so now I can go ahead and substitute. So f of 6, that's c of 6. So let's put that in here. Is equal to 9 times f of 4. And f of 4, we know it's c to the 4th power. So I'm going to put that in here. And then I'm going to divide each side by c to the 4th. Remember, it's we're dividing with the same base, so subtract the exponents. This will give me c squared is equal to 9. Finally, take the square root of each side, and this will give me the value of c, which is 3. Okay, amazing. So a great exponential function.
So continuing our journey. Okay, so this one we have y is equal to 9, 8 multiplied by a divided by 6 raised to the x plus c, and then minus b. And so how many times does the graph of the given equation in the xy plane cross the x-axis? So remember, when it crosses the x-axis, y is equal to 0, where a, b, and c are positive constants, okay, such that a is greater than 6 and b is greater than c. Okay, so first steps, first with this problem, I would plug in for when y is equal to 0, just to see how many times the graph of this function crosses the x-axis. So let's do that. Put 0 equals 9, a divided by 6 over x plus c minus b. Okay, I'm going to add b to the other side of the equation. So I'd have b equals 9, a over 6, x plus c. And then just to simplify it further, I'm going to divide each side by 9. So b divided by 9 is equal to a over 6 raised to the x plus c. Okay, so now let's look at the constraints of the problem. So first, I'm told that a, it's greater than 6. So that means that this here, so a over 6 must be greater than 1. This means then, like 6 divided by 6 is 1, so a must be 6.1 or higher. If we're dealing with integers, then should be 7. And then also we have b is greater than c, which just means that b is some positive constant. Okay, so what does this mean? We're dealing with exponential functions, and since it's an exponential function, given the parameters, it's an increasing function, which means that as x increases, this whole equation of the function, a divided by 6 over x plus c, it's also going to increase. Okay, so basically, I know it's an increasing exponential function. I can also test other limitations of the function, but if this is true, this means that it's only going to cross the x-axis at one point. Why? Because there's going to be only one condition where this, when I have these variables set equal to each other, is proven to be true. So therefore, it only crosses at one point. So this is theoretical. The answer should be 1. But just to show how you can use Desmos to help you with this one. So remember, our equation is this. I've already gone ahead for learning purposes. So I put y is equal to 9. I put 7 because remember, a is greater than 6. Raised to the x plus 1. This was the c value. And I put negative 10 because b is greater than c. And then I can also put y equals 0 because I'm trying to find where that will occur. And then we can just see if I zoom out, the function actually looks like this. I can change these numbers and it will give a similar looking function. But just to show, I can see it precisely where it crosses the x-axis. It's around here. And it only crosses it at one place. So this could be a faster alternative to use Desmos if you're not familiar with the theory behind exponential functions. I'm also going to show another alternative on Desmos. Okay, so alternative method, given the parameter, so all I did here was type in the actual equation provided. And remember you're going to be asked in Desmos to add sliders. So I'm going to do that for all of them. Then I need to go ahead and put what those parameters would be. So remember that a was greater than 1. So it's not going to be 1, but we can say it's 7. Remember, because it's a over 6, so 6 divided by 6 will be 1. So I want it to be greater. I'm just going to make it 7. If I press play, watch what happens. It only increases. Well, Okay. Also, if I do make it 7, if I want to be more precise, I would have to put that it's 1.1. And let's say this is up to 50. It can go greater than that, but just to show. So here, when I press play, I can see, it only intersects the x-axis at one point. Same with C. Remember, I put C was equal to, I had it equal at 1 because B is greater than C, so and we made B 10. So to show C, also look, it only intersects here at one point. And then also with B, looking at the slider, no matter where it goes, it's going to intersect at one point. You should put the parameters down here to fully see that it is going to be 1. But just for, learning purposes, this is how you could use Desmos. Could be a good tool. Okay, so you can use the slider function on Desmos. You can put in numbers previously like I did, or just know the theoretical relationship with exponential functions that if there is going to be a base that's greater than 1, which that would be the case, um, it's going to cross any given positive value exactly 1 time. Okay, hopefully that made sense. You can always comment if you need more clarity. So continuing our journey. So this one, for the exponential function f, the value of f of 1 is k, where k is constant, which of the following equivalent forms of the function f shows the value of k as the coefficient or the base. So I think the reason why this one was missed because perhaps the language. So remember coefficient, the coefficient in all of the answer choices here. For example, A, it's 49, B, it's 85, 144.5, and 245.65. So here I'm going to look at the answer choices. However, I can see that the winner, it's going to be C. So quick explanation, because if I'm putting an f of 1, this would be raised to the 0 power, and anything raised to the 0 power will give me 1, and then 1 multiplied by itself will give me the exponential function, in this case 144.5, and that will be equal to the coefficient. However, just for learning purposes of this video, I'm going to go through each of them so that it fully makes sense. If you got it, then skip ahead, but just to be thorough for everyone. Okay, so starting with A. So A, I would just do f of 1 is equal to 49 times 1.7 to 1 plus 1. And that would be equal to 49 times 1.7 squared. And remember, so f of 1 is equal to 49 times 2.89. And 49 times 2.89 is equal to 141.61. This is equal to the k value, and that is not equal to 49. So A can be discarded. Continuing, B, same thing. So, well, f of 1, so f of 1 is equal to 85 times 1.7 to the 1. So basically 85 times 1.7, that's equal to 144.5. And that is not equal to 85. So remember, 85 is our coefficient. So also eliminate. And then for C, f of 1 is equal to 144.5, 1.7, 1 minus 1. So that's 144.5 multiplied by 1 equals 144.5, which precisely matches our coefficient 144.5. Okay, and I would do the same for D, but I have my answer, and that's our winner. So just remember this language. I think like when you're on the exam and you see these, you're kind of like, what is this? Oh my goodness. But no worries. Just remember what a coefficient is, plug in, and life is good. Okay, Amazing.
Okay, great. What an amazing video on functions. So like, rate, subscribe if you like this video, and thank you so much for watching. I'll see you in the next video. Bye.